Hello, and welcome to our 10th lecture on Java programming for beginners. In today's lecture, we'll be looking at Java operators, and we will go further to see how you can use these operators to address specific problems, specific application problems that you might find yourself in. And Java actually has a very large number, a very good number of operators. And what I'm going to do is I will go through the list of operators very quickly. Instead of spending too much time explaining them on the slide, I'll go through them very quickly. And after we go through all of them, we would do some practicals. We would actually write code and see how these operators behave. That is when I will take time and explain each and every one of these operators to you. Like I said, the list is quite long, so don't bother if you don't know what some of them mean. Most of them are quite simple, like addition, subtraction, and so on. And there are some that I'll take much time and explain to you. But like I said, I'll not explain them on the slides here. I'll explain them when we want to use them in a program. So let's quickly go over the list. The first set of operators I have here are what are known as arithmetic operators. They are basically used for performing arithmetic operations like addition, subtraction, and so on, simple mathematical operations, and we will be explaining all of these in detail shortly. Next, we have the comparison operators that you use to compare two things. For example, you could want to compare a variable x, the contents of a variable x, with another variable y to see if they have the same value. And you will use one of these operators or to see if one is greater than the other, or to see if it meets a particular condition, for example, greater than or equal to a number. We are going to see that too. The next set of operators that Java provides for us is the bitwise operators, and these actually work on bit patterns, like a series of ones and zeros. Like we all know, computers do understand binary, and you can use these to perform different kinds of shifts in your computer, different kind of bitwise operations. But like I said, like the name specifies, bitwise, they operate on a bit by bit basis. They simply operate with binary numbers. We're going to see that shortly too. And we have the logical operators that you could use to do some intelligent decision making in your programs. You would find yourself using this a lot to control the flow of your application or to make decisions about what blocks of code to execute. Then you have the assignment operators. I'm sure we have already seen the first one here, the equal to, that is used to assign a value to a variable. For example, we are going to be seeing that shortly too. And you still have them here. It's quite a long list. The assignment operators. You actually see it's a combination of most of them is a combination of the equal sign and one other operator. It could be a bitwise operator, a logical operator, and so on. We'll talk about that detailedly when we do some practical work. Then there's there's some other operators that Java also offers. We saw the new operator that we used to create objects earlier. Now you have the conditional operator. This is also used for decision making, and we'll see that too. And this one, the instance of operator, it's actually used with objects. It has to do with inheritance and all of that, and we will not talk about that right away. We'll go through all the other operators, but we are going to leave this one after we talk detailedly about objects and we talk about inheritance. We are going to come back and we would now talk about the instance of operator. So with that said, like I mentioned earlier, I won't waste too much time talking about each of these operators right now. Instead, we're going to go directly and do some practical work with them so that you actually see them in action in that manner. I believe if we do it that way, it's going to stick better instead of just talking about them, not doing anything. So with that said, let's get to that. So fire up your NetBeans or any other IDE if you're not using NetBeans, and I'm just going to right click on my folder here, my package here, and I will create a new class and I'll call it calculator. Now remember, we said earlier when we look at naming conventions, it's recommended to use nouns for your class names. I mean, when you're writing a class, it's definitely supposed to represent something, and you should use a noun for that and try to make them reasonable enough. Let them reflect exactly what they are supposed to be doing. So in this case, since I'm doing some light calculations, I'll call my class calculator. All right, so I'll go into the class and I'm going to create a few methods. Public void. Let me create some variables that we'll be using first. Int x is equal to 10, y is equal to 5. I'm sure we saw this syntax for declaring and initializing multiple variables of the same type in a single line, and that's what I'm doing there. You could go ahead and play with some different declaration syntax to see exactly what you get. So I'll just declare a variable, public void add, and I'll declare another variable inside here. I'll call it int sum, and there we will store the sum of x and y. I'll just write all of them, then I'll come back and explain. Here I'll put public void subtract. Remember our method syntax. Every method must have an access modifier, a return type, and a name with a set of parentheses and a body. And in this case, my return type is void because I'm not returning anything from the methods. So I will go ahead here and I'll say int difference. I'll just call it diff is equal to x minus y, and I'll print it out. System.out.println. Like I said earlier, the println statement, the println statement prints the string you pass into it and prints a new line at the end of the string, so that the next time you print, it continues on a different line. I'm sure you're familiar with something like this in a language like C or C++. So I'll say x minus y is equal to, and I will print the value of diff. I'll just copy this, paste it up there, so that we print the sum of our addition, and I'll say sum. Now remember, just to mention, something just came up, I recall, so let me mention that as well. Remember earlier I said the plus sign actually is also used as a concatenation operator. Let me not talk about this one. Let me talk about this one there. Yeah. Now you can use the plus sign. We are seeing the plus sign now as an arithmetic operator. It is used to do addition. It adds two numbers, two values together, and gives you the sum. So it's going to take the value of y and it's going to add it to the value of x, and it's going to assign the result to sum. In this case, plus is acting as an arithmetic operator. But down here, this plus here does not act as an arithmetic operator. Instead, it acts as a concatenation operator. What's happening? Every time you use the plus sign with numbers, for example, it's going to act as an arithmetic operator and add the two together. If you use that with characters as well, it will do the same thing. We will definitely come to that later on. But when one of the operands is a string, in this case, for example, sum is an integer, which is the result of this addition here, and this is a string. Remember, strings are put in double quotes. So once it's inside the double quote, this is an entire string. This is the same like writing something like John is happy. So this is a string, and once one of the operands is a string, the other operand is converted into a string and concatenated to this one. So what's going to happen here is, while plus is used here for addition, when it gets to this point of the code, because this operand to the left is a string, sum is going to be converted into a string, and then it's going to be appended to this other string to the left. So you can now see that the plus operator works both as an arithmetic operator and as a concatenation operator. Alright, that's it. Subtraction. The subtraction operator, what does it do? It subtracts the value of the right operand from the left operand. And here, what are we doing? We're assigning the result, the difference, to the variable that we declared difference. Alright, now let's go ahead and write out something for the others. Public void multiply, and I would say int product is equal to x times y, and I will do the same print out there. X times y is, and I'll add the product to that, concatenate the product to that string, and I will go down here and do public void divide, and I'll say int quotient. The quotient is equal to x divided by y, and I will print out the quotient there. Sorry, not all of that. X divided by y should give us this. Alright, now we have seen this. I'm sure we are all familiar with these operators in our daily mathematical operations. We do simple additions, multiplications, and divisions every day. So what's going to happen here is we're simply going to multiply the value in x, which is 10, by the value of y, which is 5, and we will print out the product. What's going to happen down here is x is divided by y, and the quotient is printed. The quotient is printed out as well. So let's run this. Remember, our program always starts from the main function, the main method, and there is no main here. I have a main method inside one of these. All of these classes here make up my entire program. But like we saw in our previous video, when we talk about program execution flow, we saw that the programs actually start from the main method and end in the main method. So what's going to happen here is I'll just take off all the code that I have. You could comment it. A shortcut to comment in NetBeans: hold Control, highlight the code you want to comment out, hold Control Shift, and type C and press C. Control Shift C will comment it for you, but I don't want to comment it out. I want to take it all out. You could comment yours. I'm taking mine out, and I'm in my main method right now. You could go ahead and create a main method in the calculator class as well, or you could use the one we already have in our program here. But remember that your application should have just one main method. Don't put two. If you do that, you just end up confusing yourself. So what I'm going to do is I'm going to instantiate, because I have to call these methods. Now let me mention this. Inside a class, if I'm in the calculator class, for example, I could create a method here, public void display. Yeah, I'll do that. And inside display, I could call all the methods of this class. I could start by add, and I could go further and call subtract, and I'll go further and call multiply, and I'll go further and call divide. Okay, you would see, like I said earlier, to call the methods of a class, you need to, first of all, you declare the method in the class, And what happens? You call the method somewhere else by using the method name, the set of parentheses, and a semicolon to end the statement. If the method had arguments, then we will pass arguments inside here to do the call. For example, if we had int value, some value, then before calling divide, I have to pass in some value that is an integer. But we don't have any value, so I'm going to take that out. But now, how is our program going to run? Our program starts from the main method, and we have just written this code. We have not written any main method. So when we run the program, this is what will run, and we'll have no output because there is nothing in our main method. So how do we call the code in this class? From here. Now, if I try to type add, this method, when I do this, there's no add method inside this class, so there's no way I can access the add method. I can use it here. So to do the call from another class, I first of all need to create an instance of that class. And how do I do that? I declare a variable of type calculator. I'll call it calc. I'll call the variable calc, and I'll say it's equal to new calculator. Remember, the new operator. When we use the new operator, we create an object of that type and we store it in memory. When I do this now, Java will create a real calculator for me in memory, and I can now use the calc reference. I can now use the calc variable to call the different methods. Now you see I have access to add, I have access to display, but since I have put all the calls in display, I'll just call display. If I wanted to call each of them, I'll put add and I call, and I do another one for subtract, but I'm calling all of them in display. Later on, we're going to see how you can restrict all of those other methods. For example, the add, subtract, I'm going to make it restricted just to the calculator by using the private keyword on them and instead calling display from here. But for now, our focus is just to display how the different operators work. So let's go back to it. We see we are doing an addition here, subtraction, multiplication, and division. Okay, let me run this, then I'll come back and show what I wanted to demonstrate there. Now, if I run this, you will see exactly that. 5 plus x. Well, if you look at our class here, you see that x is 10 and y is 15. So we say 10 plus 5 is 15, 10 minus 5 is 5, 10 times 5 is 50, and 10 divided by 5 is 2. Alright, there's something I want to show you here now. You see, this is a division. And the division of two numbers is most likely going to result into a fraction. Now, I'm going to change this. You see, it's an integer, but that is very risky. Now, let's say the value of y was 13. Now, when we run this, it's going to give us a fraction. But now we look at what we have done here. I've declared my variable as of type int. What do we expect? Let's run it again and see. You see, the division is giving me 2. It's supposed to be 2 point something, right? So I have a problem there. Now, Java is not going to complain because it assumes you know what you're doing. You're dividing and you're putting it inside an integer. Integers cannot hold decimal places. So what it's going to do there is it will simply truncate off the decimal places and use the whole number part of the quotient that you get from that division. So to free yourself from things like that, make sure when the result of your operation, of your mathematical operation, is going to be a float, or is most likely going to be a floating point number, then declare that variable to be of type float. Now let's run it. I have 2.2. Okay, let me see why that is. Yeah, I'm going to make sure all of them sorry, I'm going to do this down here. I'm going to typecast it into a float. If that does not make much sense right now, just accept it. All right. Now, you see, when you use two integers, if you use like this, what am I doing here? I'm using the integers directly, and what's happening? Java is they are all integers, so it's treating all of them as integers, and immediately it gets the result. It truncates the fractional part and it stores it inside here. So that's why when I still run this, you see I have 2.0. So to do that, to address that problem, you could force Java to treat that as floating point numbers. And what I'm doing here, this is what is known as typecasting. What I'm doing is I am casting this into a float. I'm casting X into a float and using it in the operation. So because one of them is a floating point number, Java automatically promotes the other one into a float. And the result, now I get what I expect. So you want to be very careful with that. If all of these are integers, Java is going to treat them as integers and is going to truncate the fractional part. So you can force them to be treated as floats. Because you're doing a division, you expect something. You can force them to be treated as float by casting one of the variables to a float. And in that case, when you do that, Java automatically treats them as floating point numbers and you get appropriate results. Now, with that said, I believe this casting should have been the only strange thing to you with these operators. Now, I'm sure the only operators that would be strange to you are the modulus operator, that one, the one that looks like a percent. Actually, it's a percent symbol. And then you have the increment and the decrement operator. So let's write something with them, and I'm going to explain what they do. I'll take out these calls. Let's focus on the things that might be new, but certainly not very new if you are coming from another programming language. So I'll say public void get remainder, and inside here I'll declare a variable int remainder is equal to x modulus y. X mod y. I'll go down here. Okay, I'll print the value, the result, or the remainder. We'll talk about that. I'll come back and explain that when I finish writing the other two. So I'll just say modulus remainder. And down here, I would say public void do increment. And I'll say int value is equal to okay, I'll call this whatever, value is equal to y plus plus. And I'll come down here and I'll say public void do decrement, and I'll say int value is equal to x minus minus, for example, and I'll just bring them all out. The value of y is now plus y, and I'll say copy this one and I use it down here. I'll say the value of x is now x, and I'll go back inside this my display method and I'll call get remainder. Okay, now that that has been written, let's explain how the modulus operator works. The modulus operator divides the numerator by the denominator, in this case the left operand, by the right operand, and returns the remainder. Remember, when you use division, it divides this by this, and then it returns the quotient. Instead, the modulus operator, it does a division like x divided by y, and then it returns the remainder. So there are no fractions here, like see it as fractions forbidden. When you did simple long division, when you divide, you do carry one, do this. So in this case, we are carrying the remainder. So we're going to divide this by this. Now, what is x? Let me start by this, 10. 10 divided by 5 will give us 2 remainder 0. So what's going to happen here is this remainder should now contain 0, since the remainder of 10 divided by 5 is 0. 10, x is 10 and y is 5. So if we run this, we expect to see x mod y is equal to 0. I'm going to use it in another statement here, system.out.println, and I'll say 13 mod 10 is equal to, and I'm just going to do it here. I'll do the 13 mod 10 here. I'll do 13 mod 10. So what's going to happen? It's going to do the modulus here and append the result directly to this. So if we do 13 divided by 10, what's the result? 1 remainder 3. So we expect the remainder to be put inside here. So I'm going to run this again, and I see 13 mod 10 is 3. I continue. Okay, since we have used that and we have seen that, I'm going to add another stuff down here again. And I would say 5 mod 2. 2 and 5. So 5 divided by 2 will give us 2 remainder 1. So we expect this line to produce 1. And that's what we have there. So the modulus operator divides the left operand by the right operand and returns the remainder. The remainder, that's what it returns. Now, if we have 2 mod 10, and here I have 2 mod 10, what's going to happen? I'm going to run it. 2 divided by 10, what is it? 0 remainder 2. So when I run that, I should see 2. It always returns the remainder of the operation. Alright, now that we get that, let's talk about the increment and the decrement operators. Now the increment operator is actually 2 plus signs put together. There is no space between the plus sign. And the decrement operator is 2 minus signs put together. There's no space as well between them. There's no space, just type minus minus. What this does is it increments, what the increment operator does is it increments a value by 1. So in this case, what is y? We said y is equal to 10. Sorry, x is equal to 10. Well, let me declare another variable here. Int z is equal to 1, for example. And I'm going to come here in my increment operator and I'll say y, sorry, I use z. let me use Z. I'll say Z is int value is equal to Z plus plus. So I'm going to print out value here. What is the value of Z? Z is 1, right? Maybe I should declare it as a local variable so that we actually see it close to where we are working. Z is 1. Now I do Z plus plus and I store the result in value. When I print value, I expect this to have been incremented by 1. Ouch. That's not going to go. Well, value will not be incremented by 1. Instead, Z has been incremented by 1. So I'm just going to take this assignment out for now first. And then I would say Z. Good. This is what I wanted to demonstrate. The other one, I'll use it later to show you that this actually works depending on the position. The value will depend on the position. Now, the increment and decrement operators work on a single operand. In this case, it's working on Z alone. What is the value of Z? Z is equal to 1. So if I come here, I'm going to copy this. I'll paste it here. And we'll see the value of Z. The value of Z is this. And the value of Z is now this. Let's see how that works. And I'll come down here and I'll call my method do increment. Remember, I'm calling it down here, and don't forget that the display method has actually been called from my main method. So now when I run this, what's going to happen? This is the method we are calling. So let's run it and see. All right, what do we have? The value of Z is 1 when we initialize Z to 1 and we printed out the value of Z is 1. Ouch. But after the increment, what happened? Sorry, after the printing, what happened? We applied the increment operator on Z. So we said Z plus plus, and you see that the value of Z is now 2. If I initialize Z to 5, okay, to 6, and I run it again, you will see that after the increment is applied, the value of Z becomes 7. So the increment operator always adds 1 to a value. In this case, Z is 6, and after we apply the operator, Z becomes 7. If Z is 21, we apply this operator, Z becomes 22. And just like that, it always adds 1 to the value. Now, let's see how the decrement operator works. The decrement operator actually works in a similar fashion like the increment operator, but instead of increasing the value by 1, it decrements the value by 1. So let's declare a variable k, like I've done here, and I'll say k is equal to 6. And now what am I going to do? I'll say k minus minus. So I'll print the value of k after this initialization, which is 6. And after that, I'm going to decrement k by applying the decrement operator. That's minus minus. Remember, I said there's no space between the minuses. Just type the signs there like that, minus minus, no space. And then I'll print it again, and we expect the value, when we print it here, the value of k should be 6, and when we apply this operator to it and print it here, it should be 5. So I'm going to run this. Ouch, sorry. I'm still calling increment. So I'll do decrement. I was beginning to wonder what was happening. Now I run. You see, the value of k is 6, and then after we apply the decrement operator, the value of k becomes 5. Now if we change the value of k to 100 and we run it again, we expect it to print 100 first and then later on 99. You see, And every time, if I apply it 2 times, for example, I say k minus minus, so it would decrement 1 from this point, and then it decrements 1 again. So down here we expect to have 98. So I'm going to run that again, and you see, and if you keep on decrementing, if I decrement 4 times now, I expect it to get down again to 96. So if I run that again, you see it keeps on. If I decide to do a k plus plus, yeah, you see it's going to decrement into 96, and then this is going to increment it again by 1, so we expect 97. Good. All right, now that we have that, and now that we have understood it, there's one more thing I want you to note about the increment or decrement operators. Now you see these two, I have z plus plus. You can also do a plus plus z, and the operator will work differently. To demonstrate that, I'm going to use it in a variable. So let me take this out. Oh, let me leave it. We'll probably need it. So here I say I'll start with 1. Z is equal to 1. Now, okay, I'll take all of this out, and I'm going to print, ouch, I'll say int value is equal to z plus plus, and I'll print out value here, value. Now when we run this code, take a guess and tell me if you know the answer. Okay, you've taken your guess, so let's run this and see if you were right. Ouch, I still forgot to do increment, not decrement now, since we have gone back to that one. So I run it again. Whoa, what happened? Okay, let me put this. I'll say value is, I'll run it again. Whoa, it says value is 1. Any ideas what went wrong? Value is 1. How is that even possible? All right, let's see how that is possible. You see this? Like I said, when you use the increment operator after an operand, it works differently from when you apply it before. Now here we are applying the increment operator after the operand z. What's going to happen here is the operand will first of all be used in this operation. So z will first of all be applied to value. The value of z will be assigned to value, and then after the assignment is done, when value already has 1 in it, then z will be incremented. So if we actually print down here, if I say this and I say z is, you would actually see that z is no longer 1. Let me print this. You see, value is 1, z is 2. What happened? The value of z was first of all assigned to this variable that we name value. Value is funny. Let me call it v, so that when I'm using the word value, we don't get confused. So I renamed my variable to v. So in this part of the of this method, at this point, when we get to this point, what happens? First of all, we start up here by initializing z to 1. When we get to this point, because we are using the operator, the increment operator after the operand z, what happens? The value of z is first of all assigned to v, and then when v has the value of z, which is 1, z is now incremented. That's why when we come down here and we print v, we see that v is 1, but z is 2. Now, if I change this and I put the operator before the operand, what's going to happen? When I print it now, take a guess. All right, if you said 2, 2, then you're correct. So you see, V is 2 and Z is 2. Now, what's happening here? Because the operator has been used before the operand, what happens? This is first of all executed. This portion is executed, which means the value of Z is incremented and then the result assigned to V. You want to be careful with that. Now let's copy these, go down there and do the same thing with the decrement operator. They work exactly the same, except that the decrement operator decrements and the increment operator increases. So now we are applying the decrement operator after the operand. From our previous note, give me your answer while I do this. Decrement. Good. I'm sure you had it right. So I'm guessing you said V is 1 and Z is 0. Let's find out. V is 1 and Z is 0. Why? Because we are using the decrement operator after the operand Z. So what happens? The value of Z is first of all assigned to V, and then later on Z is incremented. So when we print out V, we see that V is 1 and Z is 0. But now let's apply it before the operand Z, and if I run this again, you would see that V is 0 and Z is 0. Like I said, you want to be very careful about those operators. It's a very tricky operator. If you don't, well, not very tricky, it's pretty straightforward, but you just need to be careful. It applies the same. Let me say I decided to use Z here. I'll take this out and I'll say system.out.println. Oh, let me not take it out, let me comment it. Might just want to use it again. Control Shift C. So I've commented that out. I'll just come here and I'll say system.out.println, and I say the value of Z is, and I print Z plus plus, and I end it. Print, not print. All right. Now, when I run this, take a guess. What's the result? Good. You said 1. Perfect. Ouch. I still forgot to call. Do increment. Come on, dude. What's wrong with me? I called the same thing. Do increment. All right. I run it again. Now you see, Z is 1. Why? Because I'm using it after the operand. Now I'm going to shift it to this side, and I'm going to do plus plus, and I'm going to run it again. And now you see Z is 2. It incremented Z by 1. Z becomes 2, and then it concatenates Z to this string by using this plus operator. Same thing if I did minus minus, then I expect it to first of all decrement Z, so Z becomes 0, and then it appends it to this. So I do that and I see it's 0. And if I shift minus minus to this side and I run it again, you see. But if I came down here and I printed Z and I say Z is now without this part, and you will see that for the first time Z is, well, let's run it. You see that Z is now, I did not put Z. All right, so you see I decremented it. You see that the decrement was actually done on this line here. I said the value of Z is Z minus minus. What happens? It uses the original value of Z. After it has finished executing using Z for this operation, this concatenation operation, it now subtracts 1 from Z. And that's why when I print Z here without doing anything, you see Z was already at 0 because of this statement. All right, I guess that was pretty straightforward. The only two things that might the only three things that might have been strange to you if you've never programmed before would certainly have been the modulus operator and the increment and decrement operators. Aside that, the rest of the operators are what we are very familiar with. And in our next video, we are going to talk about the other set of operators. We'll probably talk about the logical operators or the assignment operators. So just sit back and enjoy. If you don't get this, go back, play the video again and again till you get it.